The next thing I'm going to do is set up my firewall, and this is going to drastically reduce my external attack surface. So the only ports or the only services that will be accessible are the ones that actually need to be accessible, or in other words, the ones that are actually scored. You can use any firewalling solution you want, whether that's UFW, Firewall D, and iptables. In this example, I'm just going to use iptables. I like using iptables because it's a low-level firewalling solution. What I mean by that is like UFW and Firewall D, they both rely on iptables. So if I try to install UFW and Firewall D, they're going to also install iptables, and they're going to use it under the hood. I want to keep installing packages to a minimum just to reduce my risk. And since it's a catch-all solution that works on pretty much any of the major Linux distros, iptables is just a nice way to go. The problem with iptables is that there are a lot of different commands that you have to run to get simple things set up, and it's kind of complicated. So I actually went ahead and I put together a template that you can use if you choose to use iptables like I am here. So if I go back to that GitHub repo and I scroll down, and under practice materials, you'll see iptables template. I can go ahead and click on that. And here's a basic script template that you can use for your iptables rules. It's going to set up all the ones that are actually necessary for your machine to function properly. And in addition to that, then you can uncomment these lines as necessary to accept traffic on other incoming ports. If you're using UFW or Firewall D, that works fine too. You'll just ignore this template. Because there are many different firewalling solutions, I'm not actually going to show myself going in and running those firewall commands. I'm going to kind of leave that up to you. We're going to actually reconvene after I run all those commands and set up my firewall rules. However, one thing I want to mention is one of Red Team's goals when they get in will be to disable your firewall. So when you're setting up these firewall rules, rather than just running the commands, I like to write them to a script. And so then if Red Team ever comes in and disables my firewall rules later on, it's really easy to get those firewall rules back up and running by just running that script. So I'm going to create this firewall script right here. I'm going to say nano firewall.sh. I'm going to start this with bin bash, so it runs in bash. And really quickly, before I actually finish modifying this file, I'm going to make it executable so that I'm able to run it later on. Here's the principle behind how we're firewalling. We want to block all outgoing traffic. Why do we want to block all outgoing traffic? Well, a lot of the times, attackers will assume that outgoing traffic is allowed. In fact, that's the default policy in a lot of these firewalling solutions. And so attackers are going to rely on things like reverse connections. So whether that's reverse shells or whether that's a command and control framework that needs to perform those reverse connections. By blocking any outgoing traffic, we're going to kind of remove the attacker's ability to use reverse connections. So that's one thing I like to do. Keep in mind that a lot of these firewalling solutions like UFW and Firewall D, the default outbound policy, so the default policy for any traffic that goes out is to allow that traffic. So you will have to explicitly set the default outbound policy to block traffic. And I'm going to do that here in iptables as well. The other thing we're going to want to do is block any incoming traffic that's not to one of our legitimate services or one of the scored services. So in this case, the scored services are my web service and SSH. So my web service is probably going to run on ports 80 and 443, whereas SSH is going to run on port 22. So I'm going to want to make sure I create rules that open ports 80, 443, and 22. However, other than those three ports, every other port should be blocked by default. So I'm going to make sure that my default inbound policy is also to block any traffic. The one other thing I'm also going to allow through is ping traffic. I actually like being able to ping my machine to see whether it's up. And there aren't really that many vulnerabilities associated with ping, so it's pretty safe to allow pings to go through as well. Anyway, I'm going to go back to modifying this firewall.sh file. And I'm just going to type all the commands out. I went ahead and I typed out all my firewall rules. So now I'm going to go ahead and save this file and I'm going to exit. And now whenever I want to bring my firewall back up, the only thing I have to do is run this firewall.sh file. So I can go /firewall.sh and that should set up my firewall. Now here's the problem. In this case, it looks like there's no iptables. And so it looks like iptables isn't installed. So we're going to have to install it using apt or yum. But remember, Red Team could have messed with our package manager. So we're once again we're going to want to check that before we go ahead and install iptables or whatever firewalling solution you're using. So if I go to etc apt, I'm going to do grep-horn. And I'm going to grep for iptables. And I'm going to search this whole directory. If you're using something like UFW or Firewall-D, both of those actually rely on the iptables package as well. So I would check both iptables and that firewalling solution. So for example, I'd first search iptables, see if there's anything there. Then I'd search UFW, see if there's anything there, if you're using UFW, right? Anyway, I'm going to search for iptables. And it looks like iptables does appear in this preferences.d/pchew file. So if I go to preferences.d and I look here in this pchew file, I'm just going to use nano to edit it. You can see that there's this interesting configuration right here that essentially what it does is it disables the iptables package so I can't install it. So if I tried to install iptables, I would say apt install iptables. It actually gets mad at me telling me that iptables has no installation candidate. And if I try to install another firewalling solution that works on top of iptables, like UFW, for example, it tells me that I can't install it because you have held broken packages, unable to correct problems. Again, that's because it can't install iptables. It even says, depends on iptables, but it is not installable, right? So I can go ahead and if I know that this configuration is bad, I can remove it. I'm going to create a backup of it. I'm actually going to throw the backup in my root home directory. So I'm just going to move this file over to my root home directory. And now it's not there anymore. So now I should be able to install iptables without a problem. So I'll run apt update just in case. And then apt install iptables. And now that I've installed iptables, I should be able to use it as my firewalling solution. So if I go back to my home directory there, and now if I try to run firewall.sh, now all my firewalls have been set up. After I set up my firewall, I always like to go back and double check that everything looks correct. So I'm going to say iptables, and I'm going to say -l and -v to print out my current rules here. And I'm going to pipe that into more so I can read them one line at a time. And I figured since I just installed iptables, it's actually, I don't think it's actually in my path. So I'm going to use the full path to iptables. I'm going to say user sbin iptables. There we go. And if we take a look at what I did here, you can see my default input policy is to drop any traffic, right? However, I have some exceptions. I have this, we're allowing incoming traffic on port 80 or HTTP, we're allowing incoming traffic on 443 or HTTPS, and we're allowing incoming traffic on 22 or SSH. We're also allowing ping, so any echo requests. The other two things that I did, and these are very specific to iptables, if you're using UFW or Firewall-D, you won't have to worry about this. By default, if you're replying to somebody who contacted you or like you're continuing the connection, those other firewalling solutions will let that go through, but iptables doesn't. So for example, if somebody tried to connect to me over port 80 to get my HTTP service, right? And then I have to respond to them, it wouldn't actually allow me to do that unless I add this special rule here. And so this special rule just says that any traffic that is related to an already happening connection, or that is in response to somebody else reaching out to us, just allow that traffic to go through. The other thing is I need to allow any traffic that is going from my machine to my machine. Because let's say, for example, my web service depends on some kind of database and they communicate with each other over the same machine. I need to allow any traffic going from my machine to my machine. There's actually a special interface that's responsible for that, and that's the low interface. So I'm allowing any traffic over low. Again, if you're using something like UFW or Firewall D, you don't have to worry about those two. And then scrolling down a little bit, looking at my output, again, where our default policy is to drop. And again, I have to do the IP table specific things of allowing any traffic for related or established connections to go through, and allowing any traffic from my machine to my same machine to go through as well. Okay. Now that we've done that, I'm actually going to go ahead and I'm going to double check that those firewall rules have been set up correctly by scanning this machine from a Kali machine that is connected to the same network. So in order to do that, I'm going to have to temporarily bring that interface up so that I can actually scan it. So I'm going to say IP link set dev ENP0S8, I believe it was, up. And that's going to bring that interface up. So if I say IPA, you'll see that that interface is up. So now I should be able to actually connect to my machine. I'm going to go to a Kali that is connected to the same network, and I should be able to ping it. So if I ping 10.0.0.11, you can see that I am able to ping it. And I'm just going to do a full port scan just to make sure that I set up my firewall correctly. While I'm at it, I'm also going to get the version of the services that are running so I can make sure that they're the latest version. And I might as well run the default scripts there. And then I'll add the other stuff that we talked about in a previous video, so I'm not going to go over it here. I'm not going to actually save my results to a file, but I will scan 10.0.0.11. And you can see we already discovered open ports 22 and 80. We'll wait for that scan to finish, and I'll come back once that scan has finished. Now that my Nmap scan is finished, I can see what sorts of information I got. So we should have only 3 ports that show up here, and that is in fact the case. We see 2 of them are open. Port 443 is closed, probably because I haven't set up HTTPS yet. I only set up a basic HTTP, so that's fine, that's expected. We can see the versions of the services that we're running. So at this point, I'd go and I'd make sure we're running the latest version. So I see Apache HTTPD 2.4.59. I can go ahead and go on Google and say Apache 2 latest version, and we'll see what we get. So going on the actual Apache site, it looks like the latest version here is in fact 2.4.59, so we should be good to go. I could also do the same thing with SSH, but for the sake of time, I'm not going to go ahead and do that. I know that OpenSSH 2.9p1 is in fact the latest version of SSH. You'll notice that we only had 3 accessible ports here, 22, 80, and 443. Any other port on our machine is inaccessible. Just for comparison's sake, I'm going to show you the ports that are actually open on my machine itself. So if I do ss-blunt to see my listening ports, right? You see we have a lot of ports here aside from just 80 and 443. So for example, we have 25, we have 995, 993, all these extra ports that are listening. But as we saw from that Nmap scan, they're not actually accessible internally. So you already have to be on this machine in order to access any one of these ports. This means that an attacker who's trying to get in for the first time isn't actually going to be able to connect to the services on these ports. I want to caution you, one of the first things that an attacker will do when they get on your machine is try to take down your firewall. And if they do that, then all of these services on all of these additional ports will then be accessible. So the best thing that you can possibly do is you can stop those services from running entirely. And that way, even if the attacker does manage to take down your firewall, it's not a big deal because you're not exposing any other potentially vulnerable services. That's something we're going to worry about later on down the line. However, for now, we set up our firewall. That's kind of our first line of defense. Remember, that's only our first line of defense. Later on, we're going to want to actually go further and stop or remove any of those services that don't actually need to be running.